Hi guys, welcome to week 3. This should be the second day of week 3 of remote learning. And what we're going to learn about today is spheres and finding the surface area and volume of those spheres. Okay, so we're going to start with parts of it and we're going to go through some vocab real quick. So you guys should have the notes that you can follow along and fill stuff in if you want. But these are the major parts of the sphere that are important for us to know. So one really obvious one is the radius. And so this distance from the center of our circle out to the edge is called our radius, which is just like whenever we do our normal circles, that's our radius of our circle. And then I just said another one. This point right here is the center of our circle. And then you have the line that goes all the way across from end to end, passing through the center of your circle, and that guy's called your diameter. So same thing. If it were just a regular 2D circle, you'd have the same information. And then the only weird one that we have is we have this thing called the great circle. So this circle that goes around the edge of the circle that cuts the sphere into two hemispheres, which is basically two halves, is called the great circle. So that's the circle that goes around the edge and it splits this sphere perfectly into two equal halves, so two equal pieces, and then we call half of spheres hemispheres, okay? And then what we're gonna do is we're gonna go through the formulas. Now, the reason why we're not getting too conceptual with these formulas is on the SAT, they give you guys these formulas. So we really just want you to be able to use them and utilize what they, how to find the surface area and volume versus trying to memorize them. So you guys can easily have these written and used whenever you take a assessment or quiz coming up. Okay, so we're gonna just do some examples here. So you have volume of a sphere is this formula right here. So volume of a sphere is going to be 4/3 pi r cubed. So we're going to take whatever the radius is and we're going to cube it and plug it into this formula and we get our volume. And then for surface area, our surface area is going to be 4 pi r squared. And so we're just going to plug in. The only thing we need for the circles is the radius. So we just have to identify what that is and plug it in. Okay, so let's do one. So first thing, we have volume of a sphere we know is going to be 4/3 pi r cubed. And in this first problem, they gave us the radius was 7. So all we're going to do is just plug this in. So 4/3 pi 7 cubed. Now I am going to show you guys how to write this exact and how to write this as an estimate in decimal form so you can see both of them, okay? So what I'm going to do in my calculator is I'm going to first plug in 7 cubed, so 7 raised to the 3rd power, and then I'm going to multiply it by 4, multiplying by 4, and I'm going to divide by 3 to do this 4/3 part here. Okay, so then that comes out to be 457.33 pi. Now, if we wanted that exact number, you can go math, frac, and convert it back to a fraction. So that's going to be, if we wanted this to stay exact, 1,372 over 3 pi, and then remember we're working in volume, so this is going to be inches cubed. Now, if we want to estimate this, we can just take this answer and multiply it by the pi. So remember the pi is right here, so you click second caret, and then this gives us a rounded answer of 1,436.7, and we're going to round to 2 decimal places. So this 5 rounds up, so 0.76 inches cubed. Okay, so both of your answers, this could be acceptable if I wanted you to leave it exact, and then this could be another acceptable one if I didn't tell you to leave it exact. So that's how you find the volume. Okay, number 2 here, it looks like they gave us the diameter, so we have to find the radius. So all we do is we take 33 and we cut it in half. So in this one, we get the radius is 16.5 centimeters. And then we just plug it in. So volume equals 4/3 pi r and then cubed. Okay, so we're going to do 16.5 raised to the 3rd times 4 divided by 3. Okay, so we get this, if we're going to leave it in pi form, to be 5,989.5 pi centimeters cubed. And then remember, if we want to make it estimated, we just multiply by pi. So multiply that answer. So this takes this answer, multiplies by pi, so it's 18,816 points. Let's see, this rounds up, so 0.57 centimeters cubed. And so then that's going to be the volume of that sphere for us, okay? All right, surface area is just the area on the outside. So think about like a basketball. This is like the rubber on the outside of the basketball versus the air on the inside. So the volume is the air on the inside and surface area is the rubber along the outside of your basketball. Okay, so surface area formula was 4 pi r squared. And so again, all we need is the radius, and they gave us the radius in this, and the radius in this one was 2.8. So 4 pi 2.8 squared. Okay, so plug in your calculator, 2.8 squared times 4, because we're going to see what it is exact. So exact would be 31.36 pi meters squared, because we're working with area, so not cubed anymore. And then if I want an estimate, we multiply, not alpha, but by pi, and we get, it is about 98.52 meters squared. So that's the surface area, or the area on the outside of our basketball sphere. Okay, 4 is very similar, but they give us the entire diameter, so we just have to find the radius. So cut 24 in half, we get radius is going to be 12, and then we just plug it in. So surface area equals 4 pi 12 squared. So 12 squared times 4 is 576 pi millimeters squared. And then if we want it rounded, again, we just multiply by pi. So hopefully this is becoming really repetitive and you guys are getting the hang of it. So we've got 1,809 point, let's round appropriately, 56 millimeters squared. So it could be either one of those answers is the rubber on the outside of your basketball. Okay, so now we're going to get into hemispheres, which are the spheres basically cut in half. And so I do want to talk through what the formulas are doing. So really what you should be doing is you should be taking these formulas up here for the regular sphere, and they should be cutting them in half or dividing by 2. Okay, so let's think what happens when we do that with the volume one. That means I'm just multiplying this whole thing by 1/2, right? So when I do that, I can simplify, let me make this a little lighter, the 4 and the 2, so that this entire fraction right here becomes 2/3 when everything cancels out, pi r cubed. So that's how they get the volume down here, is they're seriously just taking this volume formula and cutting it in half. So volume of a hemisphere is 2/3 pi r cubed. Now the surface area is a little weird, because if I take that surface area for the whole sphere, which is 4 pi r squared, and I divide it by 2, you should only have 2 pi r squared left over. But they say the surface area is 3 pi r squared, because we also have this great circle that we have to include in the surface area. So this circle that goes around the edge of the middle of a sphere, you have the circle on the inside here that also has to be included in your surface area. So this is your great circle. So I have to add, I have to add another pi r squared to it. So I add pi r squared. So if I have 2 pi r squareds plus pi r squared, I get 3 pi r squared. So that's why you have to have 3 instead of 2, because I need to include the second circle, okay? Or that third, well, really third. So surface area of sphere of a hemisphere is gonna be 3 pi r squared, okay? And now we're just gonna plug it in. So again, you just need the radius. So volume is gonna be 2/3 pi, our radius in this one is 5, and then volume is always gonna be cubed. Okay, so we do 5 raised to the 3rd times 2 divided by 3. Oops, that doesn't work. 5 to the 3rd, and then I have to arrow down, times 2 divided by 3. Okay, and then that's ugly, so let's do math frac. So this, if we're gonna leave it exact, is 250 thirds pi kilometers cubed, because we're working in volume. And then if I want to make it so that it's estimated, again, just multiply by that pi. And so we'll get that the volume of this is about 261 point, okay, let's see, the 9s all round up, so it's going to be 80 kilometers cubed. So that's how you find the volume of a hemisphere. Really simple. You're just cutting basically the other one in half. Okay, so we're going to do it again. This one, they give you the diameter, so you just have to realize the radius is going to be 9. So volume is 2/3 pi r cubed. Let me just plug it in. So 9 to the 3rd, arrow down, times 2 divided by 3. All right, so this, if we leave it exact, is a nice one. 486 pi feet cubed. And then if we want to round and estimate, multiply by pi. So we get 1,526.81 feet cubed is going to be our volume for that hemisphere, okay? Now we're going to do surface area. Remember, surface area is going to be the area on the outside, including this great circle on the bottom of your sphere. So volume, or sorry, surface area was 3 pi r squared. So 3 circles basically. So this becomes 3 pi. It shows us our radius is 14. So I just plug in 14 squared. Go to your calculator. Hopefully this one's way easier than the other ones we've been doing. So 14 squared times 3. We get that this is 588 pi. Let's see, units are yards, squared because we're working the surface area. And then if we want to estimate, you just multiply by pi. Okay, so we've got 1,847.26 if we round appropriately, yards squared. So that's going to be your surface area for that guy. Okay, one last one, and then we have a couple of application problems, and then we're done with this video. All right, 8, so they give us the diameter again, so I have to realize the radius here is going to be 6.1. So then we've got surface area is going to be 3 pi r, which r we know is 6.1 squared. Okay, so we do 6.1 squared times 3. And so we get this is 111.63 pi centimeters squared. And I'm going to multiply that pi in. So we get that this is about 350 point, let's see, this rounds up, so that would be 0.70 centimeters squared. So again, that's just the outside of your basketball, including the side that gets cut in half, so this is your great circle. Okay, application problems. We got 3 more, guys, and then you're just going to go practice these formulas. Okay, so 9 says, find the volume of a sphere with a great circle area of 201.06 square inches. Okay, so I'm going to draw a little hemisphere. This is cutting my little sphere in half. And basically what this is saying is, this is my great circle that cut it into 2 hemispheres, and it's saying the area of this great circle right here is equal to 201.06 inches squared. All right, so remember, to find volume, we need to be able to find the radius. So in order to find the radius of this thing, we just have to set this equal to the area formula. So we know how to find the area of a circle is pi r squared. And so we know that that area is going to be 201.06. Now all we have to do is solve for r. So the first thing I'm going to do is divide by pi. And I'm just going to leave it like that. So then you got r squared is equal to this 201.06 divided by pi. And then to get rid of the squared, I do a square root. And then I'm just going to plug that all in my calculator. So second square root of 201.06 divided by pi. That is not pi. Divided by pi. And we get that our radius, let's see, did I do something wrong? Oh, I'd multiply. Second square root of 201.06 divided by pi, not multiplied. And we get, okay, all of those 9s round up. So our radius for this one's going to be 8. And then again, we're trying to find the volume of this thing. So remember, volume of a whole entire sphere, not a hemisphere, is going to be 4/3 pi r cubed. So then we just plug it in. So 4/3 pi, our radius was 8 cubed. And then we go to our calculator. So 8 to the 3rd, scroll down, times 4 divided by 3. So exact, that's ugly, so let's math frack it up here. So we get 2,048 over 3 pi, and then our units for this were inches cubed. Okay, and then if I want to give that a little estimation, we do times pi. And so this is going to be about 2,144.66 inches cubed of volume. Okay. All right, 2 more. So 10 wants us to find the surface area of the figure to the left. So this figure is made up of 2 parts. It's made up of this cone, and it's made up of this hemisphere. Now remember, we're just trying to find the outside, which is the surface area of this entire thing. So this part of our shape should not be included in the surface area because it's in between both shapes. So when I'm finding the cone, I'm just trying to find the lateral area or the sides of that cone. So if you go back to the formulas we learned, we had lateral area of cones is equal to pi RL, where R was your radius and L was your slant height. So we have a slant height of 13, and then if we find the radius here, we can see the radius is just 4.5. And then this is asking us to find the surface area of the hemisphere, but we don't want to include this part of the circle. So our original formula for that was 3 pi r squared, but we want to subtract out this great circle right here. So we're subtracting out a pi r squared. So really, we're just going to find 2 pi r squared to find the outside of this hemisphere. So just the sides of it, not including this part. Okay, so we're going to use those formulas, and then we're going to add them together. So let's find the lateral area for number 1. So we just do lateral area of cone is going to equal to pi. The radius was 4.5, and then lateral was 13. So my calculator, I'm just going to do 13 times 4.5. So we get 58.5. And then we got pi, and our units are meters squared because we're working on surface area. Okay, and then we have to find the surface area of the hemisphere, so this second part. So surface area of hemisphere, not including the great circle on the bottom, is just going to be 2 pi r squared. So this is going to be 2 pi, our radius is 4.5 squared. So then when we do 4.5 squared times 2, so we get this to be 40.5 pi meters squared. And then to get our total surface area, we just add up both of these two answers. So total surface area should just be 58.5 pi plus 40.5 pi, which gives us, let's see, I have 40.5 there, so I'm just going to add 58.5. So we get this to be 99 pi meters squared if we wanted to leave it exact. And then remember, if we're going to round, we just multiply that by pi. And so we get this as 311.02 meters squared if we round appropriately. So that's going to be the surface area of that entire figure. All right, last one. So it says the Henleys have a silo on their farm to store grain. Assuming the entire space is used, what is the maximum amount of grain that the silo can hold? So you're looking for the amount of grain that it can hold. That means we're looking for the volume of this entire shape. So again, let's check out what we got. So we've got a hemisphere on top, and I'm trying to find the volume of that hemisphere, and then we have a cylinder on bottom. So let's see, if the diameter of our hemisphere is 22, that means the radius is going to be 11. So radius across here is going to be 11, which is also going to be the same as the height going up and down. So that means I need to take 11 away from this 45 to figure out what the height of my cylinder is. So if I do 45 minus 11, I get the height of my cylinder. So just from here down to here is going to be 34 feet. Okay, and then let's see. We know how to find the volume of a hemisphere. The volume of a hemisphere formula was just 2/3 pi r cubed, and we have the radius is 11, so we're good to go there. The volume of the cylinder is area of the base, which is the big B, so this is just area of a base, which in this case is a circle, times the height, so this is going to be pi r squared. Okay, so let's go through and just calculate the volume. So we've got volume of the hemisphere is going to be 2/3 pi, the radius was 11 cubed. So then if we do 11 to the third, arrow down, times 2 divided by 3, it's going to give us a real ugly number, so we just do math frac to make it exact. So we've got 2,622 over 3 pi, and then this is in feet cubed. And then we're going to find the volume of the cylinder, which is just area of the base, which is going to be pi. And then again, these circles are the same. So the radius down here on the bottom of my circle should also be 11. So pi radius squared times the height, and the height of my cylinder is just 34. So we're going to do 11 squared times 34. And then we'll get that this is 4,114 pi feet cubed. And then to find the total volume of that silo, all we're going to do is add those two things together. So I'm going to do 4,144 plus, and I'm gonna put this in parentheses, 2,602 divided by 3. So I'm leaving the pi's out for now. And so we're gonna math frac. So this, if we're gonna leave it exact, you have total volume is gonna be 15,004 divided by 3 pi feet cubed. And then that's kind of ugly, so let's just multiply our pi in and get an estimate. So that's gonna be about 15,712.15 feet cubed of volume. So that's how much your silo is going to be able to hold. All right, guys, so now you're just gonna go do the practice problems of this. Make sure you take a picture and upload it to Google Classroom. And please reach out if you guys have any questions. I hope you guys are all doing well, and I hope everybody's having a great day. And that's it. Let's see if I can get this video to stop. Oh, here we go. All right, bye guys. Hope you're having a good week.